Connecting multiple wet niche fixtures to a single transformer is permissible, provided certain conditions are met. Firstly, the transformer's capacity must be adequate for the combined wattage of all connected fixtures. Secondly, there should be sufficient lockouts and space within the ground terminal to accommodate the wiring for all fixtures. Thirdly, ensure the fixtures are compatible with the specific transformer being used. Lastly, the wiring must be executed correctly, adhering to the manufacturer's instructions. To determine the required transformer capacity, calculate the total wattage of all fixtures. For example, if you have 3 fixtures, each rated at 150 watts, the total wattage would be 450 watts. Therefore, a transformer with a capacity of at least 450 watts is necessary. As a general guideline, the total wattage of the connected fixture should not exceed 80% of the transformer's rated capacity. This safety margin helps prevent overheating. To determine the appropriate wire size, calculate the amperage draw of the fixtures. Use a wiring chart to select the correct wire gauge for the calculated amperage. Ensure all connections are tight and secure to prevent loose connections, which can lead to overheating or electrical hazards. Ground the transformer and all fixtures in accordance with the manufacturer's instructions and local electrical codes. Grounding is crucial for electrical safety, providing a path for fault current to flow in the event of a short circuit. Always consult a qualified electrician if you are unsure about any aspect of the installation. It is important to understand some fundamental electrical concepts to properly size the transformer, select the correct wiring, and ensure a safe installation. Let's start with understanding watts, volts, and amps and how they relate to each other. The relationship between these is described by Ohm's law and the power law. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. The power law states that power equals voltage times current, or watts equals volts times amps. Rearranging the power law, we can calculate the current in amps by dividing the power in watts by the voltage in volts. For example, a 150 watt fixture operating at 120 volts draws 1.25 amps. Now let's discuss transformer capacity. Transformer capacity is typically rated in volt amps, or VA. For resistive loads, such as lighting, volt amps is essentially equal to watts. However, for inductive loads, such as motors, volt amps is greater than watts due to the power factor. When selecting a transformer, it is important to ensure that the volt amp rating is sufficient to handle the total load. As a guideline, the total load should not exceed 80% of the transformer's volt amp rating. This provides a safety margin to account for voltage fluctuations and other factors. Now let's discuss wire sizing. The correct wire size is determined by the amperage draw of the load and the allowable ampacity of the wire. Ampacity is the maximum amount of current that a wire can safely carry. The National Electrical Code, or NEC, provides tables that list the ampacity of different wire sizes and types. When selecting wire, it is important to choose a size that is large enough to handle the amperage draw of the load without exceeding the wire's ampacity. Using a wire that is too small can cause it to overheat and potentially start a fire. It is also important to consider the length of the wire run when selecting wire size. The longer the wire run, the greater the voltage drop. Voltage drop is the decrease in voltage that occurs as current flows through a wire. Excessive voltage drop can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. To minimize voltage drop, it is important to use a wire size that is large enough to handle the amperage draw of the load and the length of the wire run. Grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source in the event of a short circuit. This helps to trip the circuit breaker or fuse, which de-energizes the circuit and prevents electrical shock. The grounding system consists of a grounding electrode, such as a ground rod or metal water pipe, and a grounding conductor, which connects the grounding electrode to the electrical system. All metal enclosures, such as transformer cases and fixture housings, should be bonded to the grounding system. Bonding ensures that all metal parts are at the same electrical potential, which minimizes the risk of electrical shock. When connecting multiple fixtures to a transformer, it is important to ensure that the grounding system is properly sized and installed. Each fixture should be grounded individually, and the grounding conductors should be sized according to the NEC. The transformer itself should also be grounded in accordance with the manufacturer's instructions and the NEC. Here is a more detailed breakdown of the steps involved in connecting multiple wet niche fixtures to a single transformer. Firstly, determine the total wattage of the fixtures. Add up the wattage of each individual fixture to find the total wattage. For example, if you have 3 150-watt fixtures, the total wattage would be 450 watts. Secondly, select a transformer with adequate capacity. The transformer's volt-amp rating should be at least 25% greater than the total wattage of the fixtures. This provides a safety margin to account for voltage fluctuations and other factors. For example, if the total wattage of the fixtures is 450 watts, the transformer should have a volt-amp rating of at least 562.5 volt-amps. Thirdly, choose the correct wire size. Use a wiring chart to select the correct wire gauge for the amperage draw of the fixtures and the length of the wire run. The wiring chart will specify the allowable ampacity of different wire sizes and types. For example, if the total amperage draw of the fixtures is 3.75 amps and the wire run is 50 feet, you might need 12 American wire gauge or AUG copper wire. Fourthly, install the transformer. Mount the transformer in a dry, accessible location. Connect the transformer to the power source according to the manufacturer's instructions and the NEC. Fifthly, ground the transformer. Connect the transformer's grounding terminal to the grounding system. This should include the neutral connection. Sixthly, wire the fixtures. Connect the fixtures to the transformer according to the manufacturer's instructions and the NEC. Make sure all connections are tight and secure. Seventhly, ground the fixtures. Connect the grounding terminal of each fixture to the grounding system. Eighthly, test the installation. Use a multimeter to verify that the voltage and current are within the specified limits. Test the ground fault circuit interrupter, or GFCI, protection to ensure it is working properly. Ninthly, inspect the installation. Visually inspect the installation to ensure that all connections are tight and secure and that all wiring is properly supported. Check for any signs of damage or overheating. 10thly, document the installation. Keep a record of the transformer's volt-amp rating, the wire sizes used, and the grounding system details. This information will be helpful for future maintenance and troubleshooting. When working with electricity, it is important to take safety precautions. Firstly, always turn off the power before working on any electrical equipment. Secondly, use insulated tools. Thirdly, wear safety glasses and gloves. Fourthly, never work on electrical equipment when you are wet or standing in water. Fifthly, if you are unsure about any aspect of the installation, consult a qualified electrician. It is also important to be aware of the potential hazards of electricity. Firstly, electrical shock can be fatal. Secondly, electrical fires can cause serious damage. Thirdly, electrical explosions can cause severe injuries. By following these safety precautions, you can minimize the risk of electrical accidents. The NEC provides detailed requirements for the installation of electrical equipment, including transformers and wet niche fixtures. It is important to be familiar with the NEC requirements before starting any electrical work. The NEC covers topics such as wiring methods, grounding, overcurrent protection, and equipment installation. Compliance with the NEC is essential for ensuring electrical safety. Many local jurisdictions also have their own electrical codes, which may be more stringent than the NEC. It is important to check with your local building department to determine the applicable electrical codes. In addition to the NEC, there are also industry standards that provide guidance on the installation of electrical equipment. These standards are developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. Adherence to industry standards can help to ensure that electrical installations are safe and reliable. The installation of electrical equipment should only be performed by qualified personnel. A qualified electrician has the knowledge, skills, and experience necessary to perform electrical work safely and in accordance with applicable codes and standards. Hiring a qualified electrician can help to prevent electrical accidents and ensure that the electrical installation is done correctly. It's important to select a transformer specifically listed for wet niche applications. These transformers are designed with enhanced safety features such as GFCI protection to minimize the risk of electrical shock in wet environment. Using a transformer not listed for this specific purpose can create a significant safety hazard. Always refer to the manufacturer's instructions that come with both the transformer and the wet niche fixtures. These instructions provide detailed guidance on proper installation procedures, wiring diagrams, and safety precautions. Following these instructions is crucial for ensuring a safe and reliable installation. When connecting the wiring, use only approved connectors and fittings. These connectors are designed to provide a secure and reliable electrical connection. Avoid using wire nuts or other makeshift connections, as they can loosen over time and create a fire hazard. Ensure that all wiring is properly supported and protected from physical damage. Use cable ties or straps to secure the wiring to the structure. Protect the wiring from sharp edges or abrasive surfaces that could damage the insulation. Before energizing the circuit, double-check all connections to ensure they're tight and secure. Loose connections can cause overheating and create a fire hazard. Use a torque wrench to tighten the connections to the manufacturer's specified torque. After the installation is complete, perform a thorough inspection to ensure that everything is installed correctly and safely. Check for any loose connections, damaged wiring, or other potential hazards. If you find any problems, correct them immediately. Periodic maintenance is essential for ensuring the continued safe and reliable operation of the electrical system. Schedule regular inspections to check for any signs of wear and tear or damage. Clean the transformer and fixtures to remove any dirt or debris. Tighten any loose connections. If you notice any problems such as flickering lights or tripping circuit breakers, have them repaired immediately by a qualified electrician. Regarding ground fault circuit interrupters, or GFCIs, it is paramount to understand their function and proper use. A GFCI is a safety device that protects against electrical shock by monitoring the current flowing in a circuit. If the GFCI detects a ground fault, which is a leakage of current to ground, it will quickly trip the circuit, cutting off the power and preventing electrical shock. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas where there is a higher risk of electrical shock. When installing wet niche fixtures, it is essential to use a GFCI protected circuit. This will provide an additional layer of protection against electrical shock. Test the GFCI regularly to ensure it is working properly. Most GFCIs have a test button that you can press to simulate a ground fault. If the GFCI trips when you press the test button, it is working properly. If the GFCI does not trip, it needs to be replaced. Regarding voltage drop, it is important to consider the impact of voltage drop on the performance of the lighting system. Voltage drop is the decrease in voltage that occurs as current flows through a wire. Excessive voltage drop can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. The amount of voltage drop depends on the amperage draw of the load, the length of the wire run, and the wire size. To minimize voltage drop, use a wire size that is large enough to handle the amperage draw of the load and the length of the wire run. You can also use a voltage drop calculator to determine the appropriate wire size. The NEC provides guidelines for allowable voltage drop. In general, the voltage drop should not exceed 3% for lighting circuits and 5% for power circuits. When connecting multiple fixtures to a single transformer, it is important to calculate the voltage drop for each fixture to ensure that it is within the allowable limits. If the voltage drop is excessive, you may need to use a larger wire size or install a separate transformer for each fixture. A final note about the knockouts and grounding terminals of the transformer. Ensure that the knockouts used are appropriate for the size and type of conduit or cable being used. Use the correct size and type of fittings to secure the conduit or cable to the transformer. Do not over-tighten the fittings, as this can damage the transformer enclosure. Use the grounding terminals provided by the manufacturer to connect the grounding conductors. Do not use screws or other hardware to make grounding connections. Ensure that the grounding conductors are properly sized and connected to the grounding system. With these guidelines and precautions, connecting multiple wet niche fixtures to one transformer can be done safely and effectively. Remember to consult with a qualified electrician if you have any doubts or concerns about the installation.